first of all, my name is Marcus Karakashian. Okay, I'm the project director for KV MRT. My background is I've been in, just to bring you up to date, I've been in railways all of my life. I first started off as a young boy working for London Underground, and have been involved in what I call sort of mega projects, large projects, most of my life. Heathrow, Terminal 4 extension, Jubilee Line in London, Storebelt in Denmark, a lot of time in Singapore. I spent nearly total 18 years building mass transit in Singapore. So the original mass transit, the North-South line, East-West line, and then the North-East line, Kallang Paya Lebar Expressway in Singapore, and then just recently the downtown line and the extension to of the Circle line. So I'm pretty well experienced on MRT, okay. But I'm a civil engineer by trade. In other words, I'm a tunnel come concrete and muck man. Okay, I'm not a electronics or anything like that. But I know a fair bit about them, and I know what's required for MRT. Just to give you an update, really, in the sense of where, because I know everybody thinks, you know, MRTs can go. There's a shopping centre over there, there's a housing development over there, and you know, we would all love to see the MRT going to every location. It just can't do that. You know, if the MRT was winding like this across town, people wouldn't get on it because it just takes so long. You know, and that's why you look for a sort of fairly direct routes, and we have. Especially for the machines, the tunnelling machines, if it were underground or even on the gateway, we have sort of minimum radiuses we have to work to. You know, I mean, a train, I always people train, if you imagine a ruler and you're trying to put a ruler down a pipe, the straighter the pipe is, the ruler will go straight down the pipe. As soon as you start putting a bend within that pipe and try to put a ruler down, it starts getting jammed on the corners. And trains are like that, because it's only just like a cord with bogies, and it can only go around. And if you have it too tight, you end up having a problem going around, speed and all these things, and so you get wheel screech and all these others. So we have minimum radiuses we have to put into the alignment. So we try and keep nice directions and nice flows, maintain speeds. But we're also looking to put the railways into locations that people want to use, you know, either shopping or where you're working, or good locations that are going to pick up good communities where people are living and things like that. So yes, as I said, we would like to do that and pick everything up, but we can't. Maybe the second line will pick some things up, or maybe the third line. So we have to have a reasonable line going through. Even the line we've got is actually, you can see, it bends around a bit. But we've tried our best to pick the best locations. Can't have 5.5 kilometres running on where nobody lives, you know, and things like that. So, I think that the situation really, you know, and there's been a lot of sort of discussion of why is the alignment going through those locations. I mean, Singapore. I mean, in Singapore is a small place, and therefore it's easy to sort of put. Where stations are, picking up sort of fairly sort of major shopping areas and things like that. But KL's a bit bigger, and you know, KL is changing. I mean, there's new developments coming all the time, and so when we're building the railway, really at the end of the day, we want to try and we've looked in the sense of where the new developments are coming, whether they're new financial, you know, the new financial sort of city area, big shopping area and things like that. And you try and then, you know, put the best alignment through, picking up those things. If you can put it through all of them, great. But if you can't, then you have to sort of adjust slightly. And I think that's what's been done with the underground section that's been put through, trying to pick up some of the areas. You know, we would love to have gone directly into KL Central, because that's where everybody is, but we just can't get in there now. There's just so much stuff in there, so many foundations. So we've put KL Central as best we possibly can, and we'll make a good connection to the existing lines, the LRT and the KTM. But you know, we would have liked to put our station smack in the middle, but that will cost an awful lot of money, you know, as we had to underpin properties and things like that. And then obviously it goes on to as you're coming from there and where you are in Pasasene, and or as you call it, sort of the Chinatown area, and that's coming through, you know, coming through that there. That needs, you know, that area needs some better transportation than it is there. And I'll talk a little bit more about the tunnelling and Chinatown later, but just following the route through. And then Medaka, big developments coming up at Medaka in the stadium area, so that's where we want to go to. And then Bukit Bintang, a lot of discussion of where we're putting the Bukit Bintang station. But that's the best location. On the two ends of Bukit Bintang, the centre, I promise you, would die. It's best in the middle and let people go out from that. And that's where the monorail is, and that's where we want to connect to. So what I'm trying to get to is all these locations of where we put things that have been thought about. These are good locations. These are getting us a nice smooth alignment going through. We're not going off into tangents or you know, going off into peaks and then trying to get back online again. So they've all been thought about. Let me talk a little bit about the tunnelling. I'm a soft ground tunneler in the sense of that means that it's difficult ground. Singapore has been described as like trying to tunnel in toothpaste because the ground is so soft. I've even heard some ground in KL being described as custard. Now I thought that was the good ground because we've got some good ground and got some bad ground, so I'll talk a little bit about that. But basically KL split into two. We have what is known as the Kenny Hill Formation, and then we have the karstic limestone. And for us, the Kenny Hill Formation is sort of like sandstone shells that have been metamorphosized, so they've been sort of squeezed and cooked a bit more and made into a much stiffer type of ground, you know. But they can change in abrasivity. I mean, some of it can be quite abrasive to things, machines that are cutting it. But it also can go to very soft, and that's where somebody has described some of it as being like custard. It's been like a little bit fluid, which worries me, but we'll have to deal with that when we come to the tunnelling. But generally the Kenny Hills, you can see it in some of the big excavations when I know down by Pantai Hospital, they've been doing some excavation there. I go in and have a look, you know, you go in and have a look. You can see the sort of stand-up times, the material. You know, you can excavate it quite a big face and it will stand up. So for us, tunnel, not too bad, pretty good. And for that, we will use what is known as an earth pressure balance machine. This is a model. If you take a picture, please don't use the logo, all right? Because this is a Chinese manufacturer, but we are not using their machines. But this is a tunnel boring machine, all right, or a TBM. And this is the bit that actually does the business. This is what will be in the ground, all right? The rest of this could be 100 meters long, and this is sitting in the tunnel that we've built. And what you're doing is like this is the digger, the head, and it's an earth pressure balance machine. And what we're trying to do, and I'm very simplistically, is tell the ground nothing's changed. So we're excavating and putting a pressure against the ground. If you excavate a face or excavate a foundation, you will expect the ground to slightly relax because it's being squeezed and pressurized. You excavate it. We took soil springs and things like that, and it will relax. So what we're doing with this machine is we're pushing pressure up against the ground as we cut it. And there's a drum in that. There is a button. If I press it, this thing shall actually turn around. There's a drum, and it fills up with muck. And that muck is at the pressure that we're trying to push the ground. So we're trying to convince the ground nothing's changed. And then it allows us to excavate whatever we want to put in, 1.5 meters, say, of a plate. And then we will build that ring. And this is, and I always describe this is not Thunderbirds or where, you know, the machine goes into the ground and leaves this hole behind it. We have to line the hole that we're digging. And that's when we build our lining behind. And then this machine, and that will then be built here. And then this machine will push off that lining. So we're like building a skin, and then we're pushing off that skin. Then we build another skin, then we push off that skin. And this is an earth pressure balance machine. So the ground is under pressure in the drum, and we're pushing up against the ground and trying to convince the ground nothing's changed. The ground knows things have changed and relaxes slightly. Sorry, go on.
Sorry, can I ask you something?
Yeah.
Sorry to disturb. I'm Irene from the TV. So just now you mentioned you are from a strong background. I heard you say you mentioned last time you worked in London, right?
Yep, Jubilee Line.
So do you compare, because as well I know, London you have a lot of old buildings as well.
Yeah.
Right? So after you compare the London's old building with the Jalan Sultan old building, what is the difference? I mean the structure and all these things.
Okay.
Is it can affordable for this big?
Okay, let me take. London has got. If you look at the picture of the map of the tube, you know, the underground in London, you notice most of it is north of the River Thames. Not very much is south of the River Thames, and the reason is the north of the River Thames is what is known as London clay. It's a fairly stiff clay. In fact, to dig in London clay, I don't need a machine like this. I can use a machine with an open face. In other words, I can excavate and see the ground, because the ground has got a long stand-up time. It's a stiff clay, it stands up. So I don't have the problem. But in the south of the river, you go into what is known as the Woolwich and Reading beds, the Thanet sands and things like that. Then you have to use a machine like this. And the problem then is most of the old part of London is in north of the river or around the River Thames area. And where the Woolwich and Reading beds is quite new. So you don't have the same sort of problem. Some of the shop houses, the Chinese shop houses that you see, I'll talk a little bit about those because I know that's what, you know, if I can sort of go on, I'll talk a little bit about the shop houses and the way we want to deal with the shop houses, all right? But let me just finish in a sense of the thing. But London, every country, every location you go to is different. You know, I worked in Denmark and on the Storbelt, and they have a ground that I could put a lump of it in a cup, go like that, and then I could just pour it out. Now, you wouldn't do that to London clay, you wouldn't do that to the Kenny Hills, okay? You wouldn't do that to the Karstic limestone. They have different properties and how you're going to deal with them. So this is an earth pressure balance machine. This is what we were using in the Kenny Hills, and we're trying to convince the ground nothing's changed, okay? But the ground still relaxes, and there is a slight amount of settlement that will go to the surface. But most countries are settling anyway. Singapore is settling like nobody's been 25, I don't know where, but it's going down all the time. Now when you come to the karstic is different. I don't know what is taught in geography in schools in